Okay, let's go ahead and get started this morning, or this afternoon, or this evening, depending on where you are. So my name is Ted Pattison. I work with Critical Path Training. We're a company that specializes in education on Power BI training in particular. So let's go ahead and talk about the topics for today. So before we get started, I wanted to point out that there is a place that you can go and download all the demo files and the slides that I'm presenting. So there is this place on the internet called GitHub, and there is a URL up there. I've already copy and pasted this into the chat window for this talk, but let me just go ahead and take a quick tour. If I move over to this repository, note that there are the PowerPoint slides right there. If you click on the PowerPoint slides, it's a little bit tricky with GitHub at the first time, but when you click on it, it tries to show a server-side rendering, but there's also a download button. So if you click on the download button right here, notice that the PPTX file will flow down to your desktop, and you can go ahead and look at it. If you like the information, you want to go ahead and represent it to one of your local user groups, I think that's great. The more we can all learn about Power BI, the better for all of us. Okay, so what are we going to talk about in this hour? So with a title such as Advanced Query Design, we're not going to dwell too much on the fundamentals, but we have to cover some fundamentals before we jump into some of the other more advanced areas. So we just have a walking before we run section. There's going to be lots of demos that I'm going to do over this next hour. So extracting data from unstructured text, such as a download from a mainframe. Many of us have to deal with that. Also, I want to show some interesting things about extracting data from SharePoint lists. So I'm going to go ahead and show some examples of working with that inside there. When we pull data out of your typical SQL database, it's been modeled in a form for online transaction processing, not for data analysis. So we're also going to go through a very common scenario where you have an OLTP table schema in a database, and you don't want a one-to-one conversion as you're pulling the data in. And so we're going to talk about how to restructure the data or reshape it into a star schema for better data analysis and reporting. And then finally, the most advanced part we're going to look at is working with function queries and getting a little down and dirty with the M programming language. Okay, so let's go ahead and get started. So before we jump into a tool like Power BI Desktop and start creating queries, at the beginning of every project, it's also very important to take a moment, use a whiteboard, and discuss with the stakeholders what you really intend to measure, what you want to show. And for many of us that have worked on projects, this is fairly fundamental, but for those of you who are just getting started, trying to go ahead and use the tool before you really know what you want the tool to be doing, isn't really a sound practice. And so one of the very fundamental concepts that is important to get at first is how do we define the requirements for a project, especially when you're at a table and on one side you have a bunch of business users that don't speak tech talk or don't speak SQL, and on the other side of the table you have the database guy that speaks SQL but doesn't speak any spoken language, and you're trying to kind of be the impedance adapter between them. So what gets to be really a good practice is creating grain statements. The idea of a grain statement is it's in a spoken language like English, so business users can typically understand and they can typically articulate them to talk about what they want to measure, what type of data they want to see, and how is it broken down. So for instance, if we're at a meeting and I'm gathering requirements for a project, because someone's hired me to do some type of data analysis work or reporting. So let's go with the users and start going through what do we want to look at? Do we want to look at total sales revenue, over the last 4 years? How do we want to break things down? What was sales revenue, by year, by quarter, by month? Do we need to go down to the day level? Do we need to, determine how much is made before 12 noon, how much is made after? So determining the level of granularity gets to be very important to determine what queries we have to write. What was the sales revenue by geography? Do we want to drill down into sales region, state, city, zip code? Do we want to split things out by product and product category. Now, also, we start looking at things like not just what was the sales revenue, but what was the delta, or what was the change in sales revenue from one period to another. So quite often we'd like to be able to get the data so we can see trending in things like sales revenue and expenditure growth over time. Now, once you've got your grade statements, here's just kind of an example of a couple of them. Having these documented, having the stakeholders sign off on this is actually a great thing, because if you don't get the requirements right, one of the issues that you can have is you come back and you present, in your first meeting, well, here are the reports that I built for you. And so Bob, the VP, says, well, what about this, this, and this? And you say, well, back in our meeting, what you signed off on are these grain statements, and what you're talking about is something new. And I'd be happy to do that for you in phase 2, but just kind of really locking down the requirements, grain statement seems to be a really good way to do that. Okay, now let's move out of kind of the fluffy, fuzzy stuff, into a more technical space. So when we use Power BI Desktop as a query tool, or as what we often call the ETL for the Extract, Transform, Load tool, what Power BI Desktop gives us the ability to do is go out and discover different data sources. If you have a CSV file or a SQL database or a SharePoint list and you want to discover what are the columns, what are their types, Power BI Desktop is just about the best data discovery tool that's out there. Now, what you're going to do with Power BI Desktop is you're going to design queries to extract data from external places. And extraction, well, you need to know where the data lives, and typically you have to have some type of way to authenticate against a data source. So that's going to be, part of the query as well. And as you pull the data out, at the end of the day, you want to import it and build a data set. But after the extraction and before it's imported or loaded into the data set, we're able to transform and reshape the data any way we see fit with our tools. And the tools are what we're going to look at, over, the next hour in this session. Now, some of the basics, and my guess is that everyone who's attending an advanced session, has already worked with the query tool quite a bit. So what we know is that we're going to add query steps. And as I add a query step, it is just a parameterized action that is going to be executed, as the query is executed. And it just basically replays your query by executing step 1, step 2, and step 3. Now, behind the scenes, every single query is stored and executed as a batch of code written in a special language, which is called M, just the letter M. Now, the language used to be called the Power Query Formula Language, and so lately it has been formalized as now M, which I think at first was just supposed to be a fun nickname, now is the official name of the language. Now, also, as you use the query editor window, you can see the steps over on the right-hand side. Note that when you see a step that has a gear to the right, it typically means you can click on the gear, get a dialog box, and be able to make edits to that dialog box. And also note that either through the formula bar or through the advanced query editor, you can look at the M code directly. Now, here's some of the query steps that you're probably already familiar with. Doing things like renaming columns, converting column types, which gets to be a very big thing. As you create your query and you pull data from wherever it lives and you drop it into your data set, by the time it's in the data set, you really shouldn't be able to tell where the data's come from. And whether I pull the data from a SharePoint list or a SQL database or a CSV file, it's all the same once we start the data modeling phase. So converting types, gets to be an important thing to make sure that the base set of tables that your queries build in the data model, is all ready to go, and you've done as much work as possible in the query phase. Maybe you want to format column values. Now, typically when you do the data modeling aspect and you have something like a date column, you're able to put formatting on those, which are instructions to visuals that show the data. However, when you choose formatting at the query level, you're making a one-time change to the data, such as taking text and bouncing it all to uppercase. So formatting in the query phase is very different than putting formatting instructions in the data modeling phase. Okay, we might want to reorder columns. What's kind of funny is that while you can reorder columns in your query, by the time you push them back into Power BI Desktop, it goes back to the same order in which they're defined in the database and the columns you've added in. So you can change the way columns show up in your reports, but there's this thing that when you're looking at the data view in Power BI Desktop, you can't really restructure the columns, and it shouldn't really throw you off because it only bothers the author. By the time you get to the consumer of your Power BI Desktop project, you can basically create the order any way that you see fit. Okay. Now, another thing we typically do is we replace values, whether you're replacing null values with a default value. We'll see a couple examples as we go through. Expanding related columns. We're going to see a couple examples of that when we have tables that have relationships between them. And you have a one-to-many relationship, and you're looking at columns on the many side, being able to expand the related column and pull the one-side information into every single many-side row, gets to be a very handy thing to be able to do. Maybe we have two different tables, and there is some type of key we can use to join the tables together. Well, then we can merge columns from two tables and have a single output table. Okay. And then there's also things like splitting columns together, which gets to be, a very easy thing to do. Now, remember, you can always look at the code behind your query by looking at the advanced editor window. Now, the downside to the advanced editor window is it's no frills. It's a text box, and there's no color coding, there's no IntelliSense. However, it does give you the ability to either write code or copy and paste code, which sometimes can be a lot quicker than working through the query editor window and basically clicking on buttons. Now, also, what's very important to understand is that every single query that you run has the ability to create an output table in the data model. And so what gets to be very common is that you create queries that hook up to multiple data sources. When these queries are run, they basically generate base tables inside of the data model. But what's also important to see is that quite often you'll create a query that it doesn't really serve any purpose for it to generate its own output table. Instead, some queries just serve as input to other queries. And so you can basically disable the load feature so that you don't unnecessarily load data into your data model if it's not going to be used. Now, let's look at our first example, scraping data from a web page. Now, my apologies to people over in Norway, but we're going to jump into an example of American football. I guess we just call it football over here. And our season now is just about to start, so the Americans are getting rabid about the anticipation of the season coming up. So I have a bunch of NFL teams here. Now, what I like about this demo is that every single team in the NFL, and there are 32, are required to have a web page with their roster with an HTML table. And these tables across the 32 different web pages have to be standardized because there's a lot of applications that scrape the data off. So it creates a great demo for working with Power BI. So let's take one of these teams, the New England Patriots, and I'll grab their roster. Let's go back, and here I am in Power BI Desktop. It's the most recent version. Let me go ahead and save my work, what I'm doing inside here. And so we'll just call this one Players. And so what I want to do here is I want to go down and I want to say pull data from the web. So as we do this, we're going to be able to go out through here and we get this navigator. Now, the way things work is that when you have tables, it names them table 0, 1, 2, or 3. And it turns out that the NFL requirements is that whatever the first table is, table 0, is the table that has the active players. So let's go ahead and choose Edit inside here. Now, note that I'm going to go ahead and click on Apply Changes here. And what happens here is I didn't choose to edit the query. I just went, ran the query, and pulled down what we have inside there. So with me not doing any work, but just clicking and saying, bring down the table, we have table 0. It's not a very good name. And then also, my column names aren't very good. So let's go back into the query view inside here. So first thing I want to do is let's go ahead and change this to a different name. Now that we've done that, notice that the editing experience is a little bit strange. I'll go ahead and hit enter, and now over here you see that we've changed that over to the Patriots. We can do things like step through, and let's change the column names. We'll change the first one from the # or Octothorpe over to number. Now here's a neat little trick. They've given the name of the player as last name, first name. So in Power BI, it's pretty easy for you to right-click on a column and say, I'd like to split that column by a delimiter. Over the months, Power BI Desktop has gotten pretty good at guessing that, oh, you want a comma delimiter to split these up. Okay, so now I have them split out, and I could name this one last name, I could name this one first name. But instead, let's just go ahead and reverse the columns. And now let's take the two columns, select both at the same time by holding down the Shift key. And now let's go ahead and merge the columns together. So when I merge the columns, let's go ahead and put a space in between them. And let's give this a column name of player. And so now I've taken what used to be last name, first name, and just changed it to the regular first name, space, last name inside there. Okay, now some of the other things that we'd like to do is let's go ahead and bring up choose columns. And as I look down here, what's the data we really need? Let's say that the college that the player went to is unimportant for this particular data analysis project. So we'll get rid of columns we don't need. Next, we want to make sure that certain columns have been converted to numeric data. If it's not converted to numeric data, it's much less functional for me. I can't do things like sum and average and find means and standard deviations. So let's go ahead and start with weight. So with weight, I can see that it's 1, 2, 3 up there. So what I can see is that weight has already been, converted over to the whole number type. Okay, I look at age, and age is all good to go. I don't have to change anything inside there. Now, next thing we'll look at is experience. So let's go ahead and change the name to experience. And the problem that we have here is it could not convert this to a numeric field because it shows the number of years someone's been in the league. But for people who are in the league their first year, we call them rookies. And instead of a 0, we have an R. So what we're going to do here is we're going to do a replace values. And I'll say, let's go through this and take every instance where we have a value of R, replace it with a value of 0. And so now that we've done that, now we can successfully convert this over. Okay, so let's come back over here and let's go ahead and do my conversion to whole number. Okay, now let's hit this tricky one over here. Here is height. I'm going to go ahead and move height all the way down here just for working with it here. Now the problem with height is I have 6'3", 6'2", 5'11". How am I going to turn that into a numeric form? And the answer is you just have to get a little creative with your tool. So I'm going to right click and I'm going to choose split column by delimiter. Now what you can see is Power BI Desktop was smart enough to see that many of the columns have this hyphen inside there. So it guessed correctly that we want a custom delimiter of hyphen. We'll go ahead and now we've split this out. So now that we split this out, let's go ahead and take the first column and we'll name that feet. Make sure that it is a whole number. Second column, we'll go ahead and we'll call that one inches. And once again, we make sure that it is converted to a whole number inside here. And now what we're able to do is let's go to add column and let's add a custom column. So now we go ahead and we add our custom column. We're going to call this height, and here we have to actually write code in this programming language called M. However, writing M code is not very difficult in this particular scenario. because what we're able to do is, let's open a parenthesis. Let's go ahead and take the number of feet, and we'll use the asterisk to say multiplied by 12, and then the plus sign to add the number of inches inside there. And so now that we've done that, we'll go ahead and choose OK. And what we can see is now we have the height inside there. Okay, and now that we have the height, let's go down here and make sure that it's converted to a whole number. Okay, and so now what we have is we have the weight, we have the height, we have the age, have the experience. One other thing to note is that we had to, during the query, as it's going through this execution of a sequence of tasks, what we call the query pipeline, we had to produce these two different columns, feet and inches. But these things are not needed in the output. So what gets to be common is you generate something in the middle of the query, but then there's no need to hold on to it. I'm going to go ahead and delete those columns inside there. So at this point, let's go ahead and close and apply. And so what you've seen right here is I've done a lot of work to take data that was not numeric and basically put it into a numeric form inside there. So there's weight, age, experience, there's the player, there is the height inside there. Remember I talked about the columns and you can't really change them as far as the ordering goes? So what you'll see is that the columns show up in the order in which they're defined in the data source. And you can see that both player and height are columns that I created, so they come up the end. So you can sequence the columns any way you want when you show them on reports, but when you're in this data view, some people are thrown off and they keep trying to find ways to change the order in the columns, and I guess it's just not a very high priority for the Power BI team. There's lots of other more important things that they need to get to. So just if you're fussing over that, just accept the fact that the order is the way it is. Okay, so now we've done that, let's go ahead and move back to the slides. So that first demo basically just showing that we wanted to be able to take data that's not in a very good numeric format and to basically have our query process the data, convert it, and get it into a better state. Now, other things to think about is that when you work on a Power BI desktop project, you're basically creating queries and you're doing data modeling, but there are two very distinct phases. So the first phase is to design the queries to generate a set of base tables in your data model. And then the next phase is to perform data modeling tasks on the base tables. What you'll see is that some tasks can either be done in the query or they can be done in the data model. Converting a data type would be a great example. For me, I always try to do things in the query if you can, so that you don't have to do it in the data model, or so that you're not doing extra work in the data model, which might have to be done at runtime, or you might, be loading unnecessary amounts of data into your data model. If you're able to, basically accomplish the same task within the query, and then basically skim down the data that you actually have to, dump into the data model when you are done. Okay. Now, another thing I wanted to point out is that there are a couple different commands that we have that we can run on queries. So we can either duplicate or reference a query inside there. Now, for instance, let's say that I go back and let me bring back the query editor window, and let's go ahead and if I right click and I say duplicate, what happens is if I look at the first query, well, here are all these different steps that I have over here, and so when you do a duplicate, you just basically get a copy. Now let's say we find a different team over here. So we'll go back here and we'll find, how about the Green Bay Packers? That's the only team that's owned by the players. All the other teams are corporate sellouts. So let's go ahead and take this team inside there, and let's go ahead and switch this to the Packers inside here. And what I want to do is, let's go ahead and drill inside of the advanced editor for a second. So you can see there's a whole bunch of code inside here, but the only thing that's particular, to which team is the particular URL. Let's just go ahead and swap that out inside here, and let's go ahead and choose OK. And so what you can see now is it's pretty easy for you, to be able to, duplicate that logic and just change out the things, that affect, how the query is going to pull its data from a particular source inside there. Okay, now you've seen that. There's one other command that's important here, and this command down here is the reference. To me, it should have a much better name for this command. So basically when you do this, you're creating a second query that uses the first query as its input data source. So let's go ahead and copy this over. So now that I've done that inside there, I go back and notice that we haven't duplicated all the M code. Instead, we just have something that says the source, equals this other query inside there. Okay, so now you've seen that. Let's go one step further, and talk about combine queries. So let's say that I wanted to have, 3 queries that were all rolled into a single output right here. So one of the ways that we could do that, and let's go back inside there, is, let me go ahead and delete this. Now that I have deleted that inside, I'm going to go ahead and duplicate it one more time. Let's go ahead and pick one more team inside here. I live in Tampa, so we'll go ahead and grab the Tampa Bay Buccaneers inside. And so I'll come back here. We'll go ahead and change this to the Bucks. And then here, notice that I could go back to the advanced editor. If I click on source, I could click that inside there. Also note that since I see a little gear, if I don't want to get off into code land, I can basically, use these dialog boxes inside here. Go ahead, choose OK, and now it's been updated inside there. And so now what you see here, is we have 3 different queries. So let's say that I wanted to take these 3 tables, and note that, they all are going to have the, same set of columns at the end, and I want to pour them into a single output table. So I'm going to pick one of them arbitrarily. I'll pick the Patriots. I'm going to right click and I'm going to say reference. So now I have a new query. I'm going to call this one players, and what I'm now going to do is with players that now just contains the Patriots. Let's go back to the Home tab and the append query, and we want to append some other things inside there. So notice that I can append any other table. If you have multiple tables, I can also come down here and say take the Packers output, take the Bucks output, and let's dump them all into a single data source inside there. If I go ahead and we do a sort ascending, we can see that there are multiple players with number 2 and number 3, so we know we have, the things being aggregated together. One other thing that if you start doing this and you have some queries, that now are pushing their data, let's go ahead and do a close and apply. And what I want to show you here is that, well, now we've got 4 tables as output, but maybe I only wanted the 1 table players. So here's a case back here. Let's go back into queries, and let's take Patriots, and we're going to say enable load false. And so what's going to happen is that these queries will no longer build tables into the data model. And so now that we've done that in here, let's go ahead and do one more close and apply. And what we're going to see is that now we just have a single table, and it's basically just a union, of all the data sources I'm working with, pulling all that data, into a single place right there. Okay. Now, one last thing that you might do is that you might decide, especially if you start getting 50 or hundreds of queries in your project, there's a way that you can add queries to groups inside here. So for instance, let's say that we'll create one folder for extract, and so now what we're able to do is we can put these particular queries that aren't going to be inside the data model. We'll go ahead and put them in this one particular group inside here. Okay, now what I don't like is that it still puts everything else in other queries if you don't put it in a named group. I wish I could change other queries to something different. So I'm going to say move this to new group, and maybe I'll call this one data model, just to differentiate, that this is tables that are being pushed into the data model. Once again, with other queries, it just kind of shows up there, and unfortunately, it's just kind of a vestigial limb of sorts inside there. Okay. So now that we've seen that, we've kind of seen the idea of combining queries together, and also this idea that when a query is not used to generate an output table, but it's used only as an input to other queries, well, we set its enable load to false, so it doesn't generate an output table, and we want to keep the data model as lean as possible, never loading unnecessary data inside there. Okay. Now we've seen that, let's look at a couple more examples. Let's say that you have some unstructured text data. As a for instance here, let's go back to our code in the Power BI Party Pack, and what we see inside here, or what I thought I had inside here, I guess it's somewhere different, is that there is this file. Okay. Give me 1 second. I know I have that in a different place. So let me go ahead and grab that file. And with this particular file, 1 more second, let me put it back in here so that it will be inside of the Power BI Party Pack. Okay, now let's go ahead and open this up. So what I want to show here is a typical example of you have some text file. Let's just say that a mainframe, looks at the accounting system and the ledgers and basically is able to output the expenses, for this particular year inside there. So what I need to do is go in and consume the data. Now, what we'll see is that several lines of data inside these files don't have anything for us. And the lines that do have data have fixed widths. So if I count this, how many spaces or how many characters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the first one has 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the next one has 24. So by knowing, the size of your columns, that is step one. Okay, now let's go back. And what I'm going to do is create a new project. And with this new project, what I'd like to do is just show how to extract and clean the data. So let's say I want to get data from a text or a CSV file. Okay, so with that, let's go ahead and open up this file. As we open up this file, it's trying to say, is this comma delimited? Power BI Desktop is trying to guess, and it can't guess correctly. So I'm going to have to say, we have fixed width data inside here. Now, the next thing we have to do is we have to tell it where our columns start and end. So the first column starts at 0, ends at 12. Next one ends at 24. Next one ends at 48, and so on. So now that we've got that inside here, what you can see is it's able to go through and basically delimitate and pull out discrete columns in the rows that have data for us. So now let's go ahead and load this in. Now, one of the things we need to do is get rid of all these rows that don't have valid data inside there. So an easy way to do that, let's start with the first column that has the date inside there. So let's change the column name to date. Next thing that I'm going to do is I'm going to right click. We're going to come down, and what you'll see is under transform, there are going to be two important operations. There's trim and clean, and we're going to go ahead and execute each one of those. Now, the idea of trim is it gets rid of all the spaces before and after the values. And then clean is very important because it removes the non-printable, non-visible characters that always mess you up. And now that we've done that, let's go ahead and convert this over to a date. And what we see is that some of these convert over great. Others have errors. Well, obviously the rows that generate errors, we don't want those. So note that if I right click, there is a remove errors. Those rows go away. Also, some have null values, so we can also, remove the ones that are empty, and all of a sudden we just have rows of data inside there. And now that we've got that, it's just a matter of, here is the amount. And, once again, I think it's just a good practice to do a trim and a clean because it's just going to increase, the chances that your data, is cleansed. And after that, because this is currency, I'm going to switch it to fixed with number inside there. Okay, that's great. Let's keep going through here. And next one we have, is what is the category inside here. Forgive my spelling, but once again, we'll go through and we'll just do the trim, and we will do the clean transforms inside there. And same thing here with the description, and we'll go ahead and do the same type of information of trim and clean. And at this point, now I've got my data. Let's go ahead and do a close and apply. And now I have my data, and I've converted dates and currency values the way they're supposed to be. And now I have a good basis for creating some type of a report on top of that. Okay. Now, next thing I want to do is look at SharePoint. Now, SharePoint has some interesting things with it. And in particular, I want to show a couple things. Let me go ahead and open up a project that is inside of the demo files for this particular session. Also, let's go back up here, and let me go back to this team site. And as we get to this particular site inside there, that's not the right one. What I want to show here is kind of a simple expense report. So let's say that we have this list of expenses. So here's just a regular SharePoint list. And as I look at the data inside here, you're able to enter description, category inside here. There's an expense date and expense amount. Okay, and then also we have these expense categories. So we decided to put together expense budgets. So with the budgets inside here, you can see that we have pretty much a budget for each quarter for each budget category. Now, when I look back here, here's kind of the finished report inside there, but let's look at these queries inside here. Now, with these particular queries, what I want to show you is that down here, note that we have SharePoint tables sub-0. Now, let me create another query and make a point here. So I'm going to create a new query. And so when I create this query, let's go to Online Services, SharePoint Online List. There is the URL inside here. And so first thing, it's going to make you authenticate. Now, because I already have queries that are going against that same SharePoint site, the credentials are cached. It didn't make me log in. Now, one pain with SharePoint is that Power BI Desktop doesn't really understand the hidden list attribute, so it shows you all these behind the scenes lists. Now, I'm going to pick expenses, And when I do that and I go ahead and choose OK, it also is going to automatically include every single column inside here. Now, let's go back here, and what I want to do is once this finishes and comes back, and I do a choose column, well, notice that here's all these behind the scenes columns in SharePoint you typically would never want to query and pull in. So let's go through here and just say, well, I want the ID, I want the title, and I want the expense data inside there. Okay, let's go ahead and choose OK. Okay, there's the data inside. Let me go ahead and take this, and I'm going to call this one Query 1 for this particular example. And let's go ahead and close and apply. And as I do that, let's go ahead and look at Query 1. Okay, Query 1, not that much data. Great. Now, let's go ahead and bring up this tool, which is called Fiddler. What Fiddler is going to allow me to do is, if I come back here and I now do a refresh of that particular query, we can see that Power BI Desktop, is now kind of reaching out inside there. One thing to note is it doesn't grab onto the list by its name or, its title. Instead, it hard codes the GUID inside there. Okay, the other thing to see here is if I go and I look at the JSON, even though I've only asked for a certain number of columns, it's not doing column folding. It's bringing back every single column from the SharePoint list. So how can we fix that? So back here, let's go back and look at Query 1. And as I look at Query 1 and look at the very first source inside there, note that we have API version 15. So this is using what we call the SharePoint 2013 REST API. It was introduced with SharePoint 2013. But this has been added more recently. So another trick you could do is go back and use the older API. Let's go ahead and switch it back to 14. Now, when I do that, what you're going to see is the big reason I'm doing this is that we're going to get query column folding. But one thing is that when you use the older 14 API, it doesn't capture the GUID for the list. It captures the name inside there. So I'm going to have to click on navigation, go back here, pick expenses. Okay, now that I've done that, let's keep moving down here. Note that when I use the 15, it added this one rename column from ID to ID1. And I'm going to go ahead and delete that inside there. But now what we can see is if we remove other columns inside here, and just give me the columns that we want inside here, let's go ahead and choose OK. Okay, so now that we have done that, we can get the exact same effect. Let's go ahead and do a close and apply. And it's using list data. So once again, this is the REST API that was introduced in SharePoint 2010 that was replaced in 2013. But as far as Power BI Desktop goes, the underlying provider for the older one is better. And as I go through here and it gets all the different expenses, you can see that it is doing query folding and it's not bringing a lot of unnecessary data back and forth across the network. Good stuff. Okay, so now that we've looked at extracting data from SharePoint, two more things we're going to look at. Importing data into a star schema is our next topic. So for this one, let's say that we're working with a typical online transaction processing style database. Some database geek, studied COD and the the different forms of how to normalize databases, and has gone through and normalized the database. So these databases are typically optimized for fast performance, not for running long queries for data analysis. Now, let's go back here, and inside of Power BI Desktop, I will create yet one more project. And as I create this particular project right here, and I'll go ahead and we'll save this one as Wingtip Sales. And now let's go ahead and get our data from SQL Server. So I just have a local SQL database. It's Wingtip SalesDB. I want to go ahead and bring that up. And so there are our 4 tables inside here. So let's say at first, I don't do any query work. I just say, take all 4 of those tables. I don't want to work on the queries. Just go ahead and load them in. So it's going to go ahead and load those. And what you're going to see is that it's going to build a data model inside of my project that looks just like the data model inside of that SQL database. Here are the 4 tables inside. Great. And now let's go to relationship view. And you can basically see these relationships inside here. Now, as it turns out, this is a great table schema for a database that gets a lot of data modification activity, but it's not so great for data analysis and reporting work. So what we're going to do is we're going to change things as we're doing the import process, and we're going to transform or reshape the data into a different table schema. So in data modeling, for data analysis, you typically hear people talking about the star schema. So that's where we take tables that are really large, that have the numbers that we want to crunch, and we categorize them as fact tables, just a whole bunch of observations or a whole bunch of experiment results. And the way that we want to take our data and break it down is into different dimensions. So for things like the customers table and the products table, those are dimension tables. And so one of the key things about having a star schema is that every dimension table is directly related to the fact table. Okay, so here's what we want to create. Now back here, let's go ahead and bring up the query editor one more time. Now the first thing we're going to do is we're going to look at invoice details, and we realize that that has the lowest level of granularity, the leaf level at which we want to basically calculate results. So this becomes the fact table. Now invoice details is not a very good name for business users. It's just not intuitive. So we're just going to go ahead and change the name of the table to sales. Okay, once we've done that, the next thing we want to do is we want to figure out how can we directly get a connection from the customers table to the sales table. Now, sales is related to invoices, and invoices is related to customers. So one of the things we can do is inside of the invoice details, now named sales, there's a column for the one-side table invoices. And what we're able to do is start pulling that one-side data out into all the different many rows. So while the invoice has the invoice date and the customer ID, we want to push that information to every single row in the sales table now. So we'll go ahead and we will take the customer ID, we will take the invoice date, and basically push that now, into our sales table inside. Note that when I did that, I forgot to uncheck the little box, and I don't want the table name in front of the column name, so I'll just go ahead and get rid of that inside there. Okay, and now let's go ahead and convert that to the needed data types. So invoice date, we'll switch over to a date. Customer ID, that's correct. We don't need products inside here. At the same time, let's go to invoices. We no longer need a relationship between two dimensional tables. So I'm going to take the customer ID and remove it from there. And now let's go ahead and close and apply one more time. And so what you're going to see here is that instead of having to go from customers to invoices to sales, now we can go directly from customers to sales, mainly because we've now kind of put the main ID inside there. Okay. So, once again, just being able to diverge, from the schema in the source database into a better schema, which is based on the star schema, gets to be an important task inside. Okay, and that brings us to our last and hopefully most exciting topic, and that is working with these things that are called function queries. Now, I'm a bit dyslexic. This kind of runs in my family. So one problem that I have is it's hard enough remembering function query versus query function, but you'll find that the community of people just aren't really sure. So you'll just see people saying function query, and then 2 sentences later, refer to the same thing as a query function. So I'm going to try to keep calling them function queries all the way through. Now, here's what we'd like to do. Let's go back to players inside here. And what I want to do is, let's go ahead and start, what we want to do is we want to get all 32 NFL teams dumped out into a single table. And what you saw is that I kind of had this approach where I could start building things out, and I've done 3 tables, so just a lot more copy and paste, 29 tables to go. It turns out there is a much easier way. So let's go ahead and start by just kind of deleting the things that we have inside here. And so if I go ahead and delete, and delete, and we're going to start again, and we're going to start again with a list that has the URLs inside there. Okay, so, and then also I'll go ahead and delete the groups and kind of just get back to ground zero for this demo. Okay, so what I'm going to do is I'm going to start by going back to our GitHub repository. And inside of our GitHub repository, there is an NFL folder, and there is that NFL teams CSV file. Now, if I right-click on raw, I can copy the link address. So now that we've done that, let's go back here, and I have this CSV file across the network. Note that you do not want to pick text CSV, because that will download the file, and then the query's data source will be based on something in a download folder. So we're going to pick web. Even though it's not HTML, works out fine. And we're going to put this URL across the network inside there. Okay, so now that we've done that, let's go ahead and choose OK. And so now what we have is we have this particular query here, and it has the particular teams inside there. And we'll go ahead and we'll just kind of change the name to teams inside. Okay, that's great. Now, next thing we'd like to do is we'd like to start basically pulling out data. Now, I'm going to take one of these values, and I'm going to create a new query. So let's go ahead and create a new web query. And this is kind of like what I did before. I'm just pointing to one of these team sites. But what I'm going to do is I'm going to build a query that I'm going to use as a template or as a function query. So let's go ahead and pick table 0. Let's go ahead, choose OK. And now that we have done that, maybe we'll come back here, take a look at this. But I'm going to go ahead and call this one get players. Now, let's go ahead and take a look at the advanced HTML. And what you can see is that we've hard-coded some things inside there. Up top here, you can also see that, it's made certain choices, about different data types and how to change those inside there. Now, what I want to do is I want to take what is a normal query and turn it into a function query. And the only way to do that correctly is to go to the editor window. Now, inside the editor window, when we call this, we want to be able to pass parameters. So the way that you do that is you define a parameter list by opening and closing the parentheses, and then using the equal sign and less than to basically create the arrow operator inside. Now, we also can come down here and basically put the URL to the roster as text inside there. And now what we're going to do is we're going to take this parameter inside, and we're going to go to the source, So now I basically just have a generic parameter that feeds this query and tells it where to get its data. Okay, now let's go ahead and choose Done inside there. And so, unlike regular queries, you can see that this function query has the fx in front of it, and you basically need to give it a URL. You know, for instance, if I grab a URL from inside here, and we come back here and we put that in, you know, you can manually invoke one of these, but that's not that interesting. You know, the interesting thing that we have, let's go ahead and delete, you know, that manual invocation, is now using this function query in a different query. So let's go back to Teams. Now, let's also do a reference inside here, because I don't want to overwrite Teams. I might want to use that. So let's go ahead and we will call this one Players. And what you can see at first is it basically just has information about each team, but not the players. So now what we're going to do is we're going to say add column, and we're going to say I want to invoke a custom function row by row, and that's basically what the custom function is going to do for us. Now, what is going to be the name of this new row? I'm going to call it Players. And then what do we want for the query function? Well, we only have one, get players. And then finally, there is a parameter in which of these columns has the value we want to pass. Obviously, it's the roster URL inside there. So let's go ahead and set that inside. So now that we have done that, in fact, one thing I'm going to do before we do this is let's not make it so we query all 32 teams at once. Let's kind of start safe, and let's just kind of take the NFC East. You know, so now we only have 4 teams. Okay, so once again, we'll say invoke custom function. Let's create a new column named Players. Let's go ahead, call get players, and pass the roster URL inside there. We go ahead and choose OK, and so now we have something where teamed players has this one-to-many relationship. And currently I get 1 row per team, but now if I expand this column, and now I basically say, you know, give me, you know, all these different values that are inside here, and let's go ahead and choose OK. What you're going to see is that now it's going through and basically pulling that for every single team inside there. Okay, let's go back here. Let's go ahead and do a close and apply. And I got some kind of an error. Let me go back and figure out what in particular the error is that we're getting inside there. Teams, okay, players, refresh the data. Roster URL was not found. Let me go back here one more time. Okay, so now that we've got that inside there, okay, let me go ahead and delete that, invoke custom players, and sorry about that, almost done here. Let me go ahead and create this one more time. Sorry, this demo is not as smooth as it should be, but now one more time we'll go back here. We will pick vote custom column and players, and there is the team and the roster URL inside there. And okay, let me move over to something. Sorry, this isn't working perfectly here, but I do have a sample inside here under NFL. Let's go ahead and open this one up, which is the NFL player stats, and kind of go through that same logic inside here. So as we go back up inside here and we look at this, you know, we have something for, you know, extracting the players inside there. Now I've split things out, you know, into a couple extra steps here, you know, but the whole idea, you know, that we are going to extract the players, by invoking that custom function inside here, is the important piece. And the idea is that now when it's time to refresh, let's go ahead. We basically just have a table and we work through the first row and find the URL and grab all the data, and then the second row, and everything gets appended into a single output table inside there. So I'm using NFL teams, but you also might have something where you have 4 SQL databases and they have the exact same table schema, and you just basically want to union the data from all 4, and by creating a simple list that has the data connection strings for each of those, you can use the exact same technique to go through and use function queries to parameterize away all the grungy work of copying and pasting and making separate queries for each of these particular data sources inside there. So that was working with function queries. Sorry my demo didn't work, but I've given you a working sample that you can just open up and go ahead and run requery, and it will basically step through all 32 NFL teams. One little point there, as you work with these, what you will find, let me go ahead and cancel this, is that there are privacy settings that can be fairly obnoxious. Once you have 2 or more data sources, they're going to basically ask you, are these data sources private, public? And so if you run the sample, either you have to go and say, make 32 different data sources public with the privacy levels, or you can also go to the current file and you can basically say ignore privacy levels inside there. So just if you want to play with it, you might want to turn privacy levels off. Okay, so now we've gotten to the end of our talk today. Just a quick plug for Critical Path Training. If you like this type of training, for end users, we have some advanced training for Power BI Bootcamp, really concentrating on working with Power BI Desktop and getting the query design and data modeling steps down, but also working with things like apps and app workspaces, to push custom solutions out to a large audience. And we also now are including some introductory instruction of using Flow and using Power Apps with the Power BI platform. And then secondly, we have a Power BI Developer Bootcamp for professional developers that gets into developing custom visuals, working with R, creating custom R visuals, working with the Power BI Service API, the Power BI JavaScript API to do Power BI embedding. And we've just added new coverage for the development of custom data connectors using the M programming language, a extensibility point that's now just gone into beta. So please visit us at criticalpathtraining.com. Other than that, we have several questions that came in. I wasn't very good at fielding the questions as they came inside there, but let me just take a minute or two to kind of find some of these questions right here. Okay, when using reference, would changing the original query affect the data in the second query? And the answer is absolutely. That's one of the main reasons that we use it. So when we do this one query to get back all the customer data, and we've done all this work to be able to clean the data and have a real good assurance that it's quality data, and then I have 3 or 4 other queries that use that, changes to the base query are definitely going to affect the queries that build on top of that. Okay, let's see. If you decide to format during the query phase or in the data modeling phase. Okay, so in general, we always do formatting in the data modeling phase. Whenever you have a date, whenever you have a currency value, in the data model, you should take that column and put, formatting characteristics on top of that, which really don't do anything to the data. They basically put instructions in place to visuals for how they should display the data. Formatting, during the process of doing queries, is very different, in the fact that, let me just kind of bring one up real quick. If I go to a particular column inside here, and I decide I want to do some type of formatting on that, such as bounce things to uppercase, that isn't just a format instruction. That's a transform of the data. You've modified the data inside there. So typically you wouldn't decide to do it in one place or the other. You would do it, only in the query if you really needed that one-time operation to actually modify the data inside there. Okay. Question way back from an earlier demo. To confirm, you were able to delete the feet and inches column if the formula for the custom height was not dependent on these columns. Well, actually, in that particular demo, I had a particular step where I used the feet and inches column to calculate the values for another column. Once that step is over, you no longer need to have the feet and inches columns. And if they're not needed, there's no reason you want to basically dump them into the data model and take up space unnecessarily. So you only need to keep those columns, around in your query when there are steps that continue to reference them. But once you're done referencing them, you can delete them inside there. Okay, I think I'll just leave that as the last question inside. Hopefully everyone had fun and learned something today. If you're interested in the developer story, on Thursday we're going to run another seminar, another webinar, and that is on Power BI Embedded, the full story. So lots of Visual Studio, C# code, TypeScript code, good stuff like that. So if you're a developer and that interests you, love to see you on Thursday. Other than that, thank you very much, and we will send out a follow-up email telling you where you'll be able to access the recording for this particular webinar. So once again, thanks everybody for being part of our webinar. Hope we see you Thursday.